Okay, so we have a Unit 2 mid-assessment that we're giving tomorrow, and so I wanted to put a little review up here. So this is the mid-test review, mid-unit test review. On number 1, it says a number less than 5. Part of what we're doing in this unit is converting words into mathematical expressions. One thing that we've taught our students, anytime we see the word less than, that's going to cause us to flip the two numbers that are in the problem. So in this particular one, when it says a number is something that, well, it's a number, but we don't know the value for it, so we use a variable. The other number we have in here is 5. Since it says less than, a number less than 5, I am going to put 5 first. And I'm just going to use n for a number. I don't know what the number is, but I will use a variable. A number less than 5 would be written as 5 minus n, or 5 minus x, or 5 minus y, whatever variable you would want to use there. Number 2, the quotient of a and 6. Well, here they've actually said, okay, so your variable's a, and we'll use a. Quotient does mean that I'm going to be dividing. So the quotient of a and 7 looks like this. A divided by 7, or the way that we actually prefer the students write it this year, a divided by 7. This is much more common to show division as they move forward in their algebraic careers. So we are moving toward writing division this way. The instructions for the next part says to combine the like terms, but also simplify. What that tells me is that I'm going to have terms that are like terms, but I'm also going to have terms that are not like terms. So let's start with the first one here. I've got 1, 2, 3, 4 terms in this problem. Terms are just separated by plus and minus signs in an algebraic expression. I'm going to go ahead and separate out all the terms. And notice that in front of each plus and minus sign is where I'm going through with my dividing out of terms here. That tells me if my term is positive or negative. And so in this particular problem, I have like terms here and here. Those are my two x terms in this problem. I can combine those like terms. This is a positive 5x, and this is actually a negative 1x. Anytime we say minus x, we do count that as 1x. So I'm going to go ahead and connect that all the way there. It looked like an I. But that's a negative 1x that I'm going to combine with this negative 5x. I'm sorry, positive 5x. So a 5x and a negative 1, that's a 4x. And you can either look at that as 5 plus negative 1 or 5 minus 1. That will get us to a 4x there. My other two like terms that I cannot combine with my x terms are my constant terms. A constant is just a regular number that cannot change. This could change based on what the variable is, but these are just regular numbers. I have a positive 3 and a negative 6, so a positive 3 and a negative 1, 2, 3, 4, 5, 6. And when I combine these guys, I'm going to mark out those 0 pairs. I do end up with a negative 3. So we can look at that as just 3 minus 6, or a 3 plus a negative 6. But this is my final answer. I have two different types of terms in this problem. So I'll have 2 terms in my answer, and we're done. I'm going to section off this next one, much like I sectioned off the first one. Right in front of each plus and minus there is where I'm going to section it off at. C terms and C squared terms, this is one of the most common mistakes. People try to combine those as like terms, but it has to be not only the same variable, but also to the same power to be a like term. So my like terms in this particular problem are my C terms, C squared terms here and here. I only have one constant term, and I only have one C term. So I see 3 different types of terms in my problem. I know that I'm going to have 3 terms in my answer. Combining this c squared, 6c squared, to this 2c squared, they're both positive. That's just going to be 8c squared. And so I've taken care of my c squared terms now. I'm going over, just to keep all my variable terms first, I'm going to go ahead and bring down my minus c. It won't combine with anything, but it's certainly part of my answer. And also my minus 15 I'm bringing down. Oops. It won't combine with anything, but again, still part of my answer. I have 3 different types of terms in this problem. I have 3 terms in my answer. I'm good to go. On number 5, it does say to explain how to solve this problem, then solve. So a couple things I'm going to do here. I am going to distribute the 3. That will be my first step. This acts as a multiplier on the outside here, and I'll multiply it by each of the things in here. I'm going to go ahead and do that step. 3 times 6, that's 18x, because I've got 6x 3 times, but I'm also multiplying this 3 times 15. That will get me 45. I'm going to keep my minus here, minus 45. The next thing I'm going to do is I'm going to calculate my exponent here, 2 to the 3rd power. So, exponent. And that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. This is going to be a plus 8. My last step will be to combine my like terms. So just to show how we did this before, I'm going to section off each of the terms right in front of each plus and minus there. And in this problem, I do have like terms of negative 45 and positive 8. My 18x will not combine with anything, but it will be part of my answer. So 18x. This is basically going to be my 2 constant terms here. I have a negative and a positive. The signs are not the same, so I'm just going to subtract their absolute values and keep the sign of the greater absolute value. The side of my answer will be negative. 45 minus 8 will be, 37. So minus 37. That's my final answer. The rest of this study guide is just going to be mostly one-step equations here. I will be combining, let me get this to the original down here. I will be combining 2 linear terms as my last problem. But up here, the way that we calculate this means 3 times something equals negative 21. We want it to be c equals. Ultimately, that's what we're trying to find. What does c equal? The way that we do that is identify what's being done to the variable. In this case, it's being multiplied by 3. We can do the opposite operation to get right back to c. If you take a number, multiply it times 3, then divide it times 3, you just get right back to that number because those operations cancel each other out, leaving that variable by itself. Whenever I do this, that leaves me with c on the left side. In order to maintain equality, this is an equal sign here, I have to divide the other side of the equal sign by 3 too. In doing that, I know that 3 will go into 21 7 times, but this is a negative divided by a positive, so it will give me a negative quotient. My answer to number 6 is c equals negative 7. All of these one-step equations are going to be about doing the opposite operation of what's being done to the variable. Here my variable is being divided by negative 6. So I'm going to multiply by negative 6. That is the opposite operation. And again, to maintain my equality, if I do the same thing on both sides, this operation over here cancels each other out, leaving that variable by itself on the left side. On the right side, a negative times a negative is a positive. I'm going to get 60. Down here, I'm going to talk again about trying to isolate the variable and get it by itself. Ultimately, in this problem, I want v equals. So I have to get rid of this negative 10 that I'm adding to it over here. The easiest way to get rid of a negative 10 is plus 10. I'm going to come over here and maintain my equality, plus 10 on the right side also. These cancel. I've already brought my v straight down. 30 plus 10 on the other side gives me my answer. We can always take what we say the variable is for our answer and plug it back into the original problem. Negative 10 plus 40 will get me 30. It checks off. On this one, my variable is being subtracted by 20. Well, if I turn right back around and add 20, all I have left over here is the number I started with, c. Over here, when I add 20, my signs are different here. I'm going to subtract their absolute value. 42 minus 20 will be 22. Got more negatives here than positives. It is a negative 22. In this problem, my variable is being divided by 13. The operation is to multiply times 13. These are going to cancel, leaving that variable by itself. 4 times 13. So let me see. Let me do 4 times 10 first. That's 40. And then 4 times 3 is 12. 40 and 12 will be 52. In my last problem over here, this is called subtracting linear equations. Whenever I'm subtracting positive and negative numbers, I like to do keep, change, switch. I'm going to keep everything here, change this to plus, and switch the sign of both the things in the second linear expression. It's just like the rules that we learned for adding and subtracting, or really for subtracting integers. I'm just applying it to linear expressions. If I wanted to on the front end, I could just think of it as, and again, I'm talking about like terms here, 2x minus 6x. That would be a negative 4x. And I'm also doing 3 minus negative 8. Well, when I subtract negatives, it's the same thing as adding positives. This turns into 3 plus 8, which is a positive 11. This is my final answer, but I just wanted to show you if I wanted to do keep, change, switch, I get the same answer. This is a 2 plus a negative 6, a positive 2 plus a negative 1, 2, 3, 4, 5, 6. Mark out my 0 pairs. I still get that negative 4 here, and I am still adding a 3 plus an 8 here to get 11. This is my final answer. If you would like to, at home, prepare for this unit test on IXL, you can do, and let me just come to a new screen here. You are more than welcome to go into IXL and do, under the 7th grade tab, you can do R dot, really 1 through 16. All of those are applicable to this section, but also S dot 1 through 5. That will cover everything through the mid-assessment that we're taking tomorrow. You can also do the rest of this S section. I'm not sure exactly how many it goes through here, but 1 through, we can do 1 through, just all of that S section. And that will actually get you through the end of Unit 2 to finish out every other aspect of this unit that we have. Thank you for listening. Good luck.